kind of teach it to you guys just so you understand it just a little bit better. So don't forget that we have that 90-degree angle, and that 90-degree angle needs to be included in your equation. So let's really quickly just go over this one more time. So if we were to write our linear equation with this diagram, we would write 3x plus that 90-degree angle. Don't forget about it. They give us that symbol right there, plus 4x. And then we also need to include that 221-degree arc. So we're also going to add in that arc. And when we have an arc, we set that whole equation equal to 360 degrees. So I'm going to set this equal to 360 degrees. And now my next task before I move stuff around is to combine like terms. So I'm going to combine my like terms in this problem. And so I see I have some numbers with x's and some numbers without x's. So I'm going to combine those numbers with x first. So I know that 4 plus 3 is 7. So I have 7x so far in my equation. And then I need to add together 221 plus 90. And when I do that, I get 311. So now on the left side of my equation, I have, it says 7x plus 311 equals 360. Now, I'm trying to get x all by itself. So my first step in solving this problem is to do the opposite of whatever's happening to that 311 on the left side of my equation. So right now that 311 is positive. So I'm going to subtract that 311 from both sides of my equation because subtraction is the opposite of addition. And when I subtract 311 from 360, I get 49. So I'm going to rewrite my equation so that I know what I have left. So I am left with 7x equals 49. Now remember, if we have a number and it's being multiplied by a letter, we need to do the opposite of the multiplication that's happening between that number and letter. So we're going to divide both sides of this equation by 7, because remember, whatever we do to one side of the equation, we also have to do to the other. So we end up with x equals 7. Now, they asked us to solve for x, so we were able to do that. But they also asked us to find the measures of angle RQS and angle TQU. And those measurements, they tell us, are 3x degrees and 4x degrees. So we need to make sure that we go back into our problem and plug in that 7 that we just found for x so that we can solve for those missing angles. So, for example, for the angle that is angle RQS, they told us that that angle was 3x. So our final step in solving for that angle, that missing angle, is to multiply 3 by 7. And when we multiply 3 by 7, that equals 21 degrees. So we know that that angle is 21 degrees. We also needed to find the angle measurement of angle TQU. And that angle measurement, they told us, was 4x. So that means that we needed to multiply 4 by 7 to figure out that that angle measurement was 28 degrees. A couple of you just forgot that very last step. So if you forgot that very last step, I gave you 8 points instead of 10 because you just missed those last two little things. So I did grade most of your exit tickets so far, and I've put the grades in Jupyter. I'm not entirely done yet. I've also commented on Google Classroom just to tell you what you might have missed or done wrong. So please do look at that if you guys are interested. But this is just one kind of final review of how we do, how we solve for missing angles when we're looking at diagrams like this one with angle relationships. So today we're going to move on to learning about properties of inequalities. And before we do that, I just wanted to review with you guys really quickly the signs that we use when we're talking about inequalities. So this is probably definitely a review for you guys, which is totally okay. But when we see a sign that looks like this one right here, so we see this sign, it's pointing, its little point is pointing to the left. That means that we're talking about something that is less than. So we call that less than. If we see a symbol like this next one right here, where that point is pointing to the right, that means greater than. And then if we see something that's pointing, a little sign that's pointing to the left and it has a line underneath of it, that means less than or equal to, less than or equal to. And then if we see another symbol, the one that we see that at the very bottom right here, if we see that and it's pointing to the right and it has that line underneath of it, that means greater than or equal to. And I just wanted to remind you guys of those symbols before we move on to talking about properties of inequalities today. So there are our symbols. And before we move on, we need to talk about just two things. So we're going to hear these statements today that say either we're preserving the inequality symbol or we are reversing the inequality symbol. So I just went over for you guys our inequality symbols that you might see today. And so what it means to preserve that inequality symbol, it means that the inequality symbol is going to stay the same. So if you're taking notes, please write this down. Means the inequality symbol, equality symbol stays the same. And I want to give you just a really quick example of what that might mean. So for example, if we see something that says 5 is greater than 2, that's a true statement. Now, if we choose to subtract 3 from both sides of this inequality, so if we say 5 minus 3, and we're going to keep our inequality symbol the same, is greater than 2 minus 3, when we carry out that subtraction, so when we say 5 minus 3 is 2, and when we subtract 2, or when we subtract 3 from 2, we get negative 1. So now we have a statement that says 2 is greater than negative 1, which is still true. We did not need to change that inequality symbol at all because our statement saying that 2, whoops, my pen's not writing, that 2 is greater than negative 1 is still true. Now, if we're talking about reversing the inequality symbol, it means that that inequality symbol is going to change. So it means the inequality symbol switches less than with greater than, and less than or equal to with greater than or equal to. So it just means that whatever we do to one side of the inequality, we're also going to do to the other. But in doing so, we change that inequality symbol. So it means that if it is currently, so if, for example, this equation that we just went over here, if we were to instead, let's say instead, we multiplied both sides of our inequality by negative 1. Okay, so 2 multiplied by negative 1. All right, so that means that this is negative 5, and we're saying that negative 5 is greater than negative 2. And that's no longer a true statement. Remember that if we look on a number line, our negative 5 would be right here, and our negative 2 would be closer to 0. So negative 2 is actually greater than negative 5. So we would have to change that inequality symbol to say negative 5 is less than negative 2. So that would be an example of us reversing that inequality symbol. So we're going to now take a look at a couple of different examples of what might happen if we do this to these inequalities. Is the inequality symbol going to stay the same or be preserved? Or is it going to be reversed or change? So we're going to take a look at that now. Does anybody need me to hold tight here so that you can continue to copy this down? I will post this on our class page after this lesson is over so that you guys will still be able to go back and look at this video if you need to. Is everybody okay? I can't see you, unfortunately. Okay, then I'll move on. All right, so we're going to look at, it's called station number 1. If you guys were in class, I would be able to have you guys get into stations and you guys would, in a group, solve these problems. But since we can't, I have gone through and given us some numbers to work with so that we can complete these stations together. So there are 4 stations, and then at the end, we're going to look at just kind of another station. It's an exercise where we either reverse that inequality symbol or keep it the same based on what they tell us. So with station number 1 here, what we are doing is we are either adding or subtracting numbers from both sides of our inequality. So I didn't fill in my inequality symbol yet. So I'm looking at this first row right here, and it says -3 is less than 5, which is a true statement. -3 is less than 5 if we were to look at it on a number line. And they're asking us as our operation to add 2 to both sides. So our new inequality says -3 plus 2 is less than 5 plus 2. And when we carry out that subtraction, we end up with -1 is less than 7. And that's still a true statement, so we did not need to change the inequality symbol in any way. So we say that that inequality symbol was preserved. When we look at 5 and -5, 5 is greater than -5. So I'm going to put an inequality symbol in there that says 5 is greater than -5. And now they ask me to add -3 to both sides of my equation. So I'm going to write a new inequality that says 5 plus -3, and I'm going to keep that inequality symbol the same until I know for sure whether I need to change it or not. So 5 plus -3 is greater than -5 plus -3. Now I'm going to actually carry out the addition of -3 to both sides of my inequality. So 5 plus -3 is 2. So here on this side of my inequality, I've got 2. And then on the other side of my inequality, -5 plus -3, remember when we're adding 2 negatives, it equals a larger negative number. So we have -5 plus -3 equaling -8. Now, I can keep my inequality symbol the same because 2 is greater than -8. So in my box over here where it says, is the inequality symbol preserved or reversed? I can say that that inequality symbol was preserved because I did not change it in any way. I left it exactly the same. Okay, so let's keep looking at these problems and see what happens to all of these inequalities when I either add or subtract a number. So now we're looking at 4 and -2. 4 is greater than -2, so I'm going to put that greater than symbol into my inequality column. And then it asks me, my operation is to subtract 2 from both sides. So I'm going to write out my new inequality, which says 4 minus 2 is greater than -2 minus 2. And now I'm actually going to carry out the subtraction of both sides of my inequality. So on one side, I have 4 minus 2, and 4 minus 2 is 2. And on the other side, I have -2 minus 2. And when I take -2 and I subtract 2 from it, I get, again, another larger negative number. So -2 minus 2 is -4. And if I look at these two numbers and I ask myself, is 2 greater than -4? It is. So I'm going to keep my inequality symbol exactly the same with that greater than sign. So my inequality symbol was preserved when I subtracted 2 from both sides of that inequality. Now let's take a look at 6 and 4. Well, 6 is greater than 4. That is a true statement, so I'm going to add in that greater than symbol. And for my operation for this row, it's asking me to subtract -1 from both sides of my inequality. Now, I want you to make sure that you understand that we are subtracting -1. So I'm going to write this out for you guys so you can see what I mean by that. So we have 6 and we are subtracting -1. You need to make sure that you're including both the subtraction sign and the negative sign because it matters. Okay, we're going to keep our inequality symbol exactly the same. So we're going to say that greater than. And then now we're going to say 4 minus -1. Okay, now remember in class when we were in school, we talked about how when we subtract a negative number, it becomes a positive. So that means that we change this whole thing into a plus sign because when we have two negatives, it becomes a positive. So when we are subtracting a negative, it becomes an addition problem. Excuse me if you can hear my dog squeaking her toy. I'm really sorry about that, guys. Okay, so we've got 6 plus 1 on the left side of our inequality. So 6 plus 1 is 7. And then on the other side, we have 4 plus 1, and that is 5. And 7 is still greater than 5, so I can keep my inequality symbol exactly the same. And I can say that my inequality symbol was preserved because it did not change at all. It stayed exactly the same. Let's look at the last row in this table and see what we come up with. And then let's look at what all of our signs, did they change or stay the same? Okay, so we have a -1 and a -4. Remember, on a number line, -4 is further away from 0 than -1 is. So we say, here I'll add a 0 in there for you. So we say that -1 is greater than -4. Okay, they ask us for our operation to add 1 to both sides of our inequality. So we now have -1 plus 1, and we're going to keep our inequality symbol the same for now, is greater than -4 plus 1. So when I carry out that operation, -1 plus 1 is 0. And -4 plus 1, remember when we add a positive to a negative, it's kind of like taking or going 1 towards 0. So now on the right side of our inequality, we have -3. So now I have to ask myself, is 0 larger than -3? So if we add -3 in here on our number line, we can see that 0 is further to the right on our number line than -3 is. So we can confidently say that 0 is greater than -3. So once again, our inequality symbol is preserved. So I want us to come down here and look at this final problem before we move on to the next table, where we look at different operations in terms of inequalities. So this is asking us to examine the results and make a statement about what you notice and justify it with evidence. So when we look at whether or not our inequality symbols changed in each of these operations, they all stayed exactly the same. So we can make a statement about inequalities, about the properties of inequalities, to say that when a number is added or subtracted to both numbers being compared, or both numbers in our inequality, the symbol stays the same, meaning that that inequality symbol is preserved. So I want to write that out so that we make sure that we understand. So when a number is added or subtracted to both numbers, and I'm just going to put a number symbol in there, to both numbers being compared, or both numbers in the inequality, the symbol stays the same. The symbol stays the same. And when the symbol stays the same, we use the term preserved. That symbol was preserved. So make sure that you write that on there. So when we are adding or subtracting a number from both sides of our inequality, the inequality symbol is going to stay the same. It's going to be preserved. That's a comma there. Okay, So that is important information moving forward as we're trying to understand the properties of inequalities. Before I move on to the next station, does anybody have any questions about this one? About anything that I did here? Okay, we'll move on to the next station then. Okay, in this station, it's asking us to do a different operation than we were doing before. So remember, before we were adding or subtracting numbers from our inequality. Now it's asking us to multiply -1 by both numbers in our inequality. So I want to firstly fill in that inequality symbol for all of our numbers. So let's look at this first row right here. It says 3 and 4. Well, I know that 3 is less than 4, so I'm going to write that less than symbol into my inequality to create my inequality. So my inequality now, I need to multiply both sides by -1. So I'm going to write -1 times 3, and I'm going to leave my inequality symbol the same, so I'm going to leave it a less than sign. And on the other side, -1 times 4. Okay, so now I need to carry out these operations. So I know that -1 times 3 is -3. So I have -3 on the left side of my inequality. On the right side, -1 times 4 is -4. Now I have to ask myself, does my inequality symbol change or does it stay the same? If I'm looking at this and I see a -3 on the left side and -4 on the right side, I know that -3 is greater than -4. It is closer to 0 on my number line. So I'm going to change that inequality symbol to make that statement a true statement. -3 is greater than -4. So they asked me, did my inequality symbol stay the same or did it change? It changed. So we're going to say that the inequality symbol was reversed. Remember, if it's changing, it is being reversed. If it's staying the same, it's being preserved. So let's now look at the next row of our inequality, of all of these inequalities, and let's see if our inequality symbol stays the same or if it changes. So I'm looking at 6 and 5. I know that 6 is greater than 5, so I'm going to put that greater than sign in for my inequality symbol. Now, my operation is still asking me to multiply by -1. So I'm going to put -1 and I'm going to multiply it by 6. And I'm keeping that inequality symbol the same for now. So -1 times 5 on the other side of my inequality. Okay, so now I need to carry out these operations. -1 times 6 is -6. So here's my -6. And on the other side, I have -1 times 5, which is -5. Now, I have to ask myself, can I still say that -6 is greater than -5 and have it be a true statement? I cannot. That is not true to say that -6 is greater than -5. Instead, I have to change my inequality symbol to say -6 is less than -5. So now I say that my inequality symbol was reversed. So I'm going to say it was reversed right here in this column. All right, let's look at that third row down for the numbers that I've written in. -5 and -6. I need to add in my inequality symbol. So I know that -5 is greater than -6. So I'm going to add that greater than sign in there. And now our operation is still staying the same. So they're still asking us to multiply both sides of our inequality by -1. So I'm going to multiply -1 by -5, and I'm going to leave my inequality symbol the same. And on the other side, I'm going to multiply -1 by -6. So now I have -1 times -5. And remember, when we're multiplying a negative by a negative, it equals a positive. So now I have -1 times -5 is +5, and -1 times -6 is +6. So now I have to ask myself, is 5 still greater than 6? It's not. It would not be a true statement to say that 5 is greater than 6. So I have to change my inequality symbol to say 5 is less than 6. So my inequality symbol was reversed. Let's look at our last row here. It says -4 and -1. I know that -4 is less than -1, so I'm going to add in that inequality symbol in there. And now I'm going to multiply both sides of my inequality by -1. I'm leaving that symbol the same for now, saying less than, but I might change it later on. So -1 times -1 on this side. Okay, remember that when we're multiplying two negatives, it equals a positive. So -4 times -1 is +4. And on the other side, -1 times -1 is +1. Now I have to ask myself, can I still say that 4 is less than 1? And I can't say that 4 is less than 1. That would not be a true statement. 4 is greater than 1. So I'm going to change that inequality symbol to greater than instead of less than. And if I change that inequality symbol, then I reversed it. Now we need to make a statement about the property of inequality that we just saw. So when we look at the operation that they asked us to do, in this table they asked us, or at this station, they asked us to multiply every single inequality by -1. And so what we can say is when both numbers are multiplied by -1, the symbol changes, or the inequality symbol is reversed. So we're going to say, I'm going to add it over here, when both sides, or both numbers, are multiplied by -1, the symbol changes. And we call that symbol being reversed. So I'm going to add that in there as well. So I'm going to say reversed. So there's our second property of inequality. We can say two things so far. We can say that if we add or subtract a number from both sides of our inequality, that the inequality symbol is going to stay the same. We can also say that when both numbers of our inequality are multiplied by -1, the symbol changes. It is reversed. So we've got two properties of inequality so far. We're going to understand two more properties before our lesson is over for today. And I am keeping an eye on the time. All right. So let's move on to station number 3, as long as nobody has any questions about station number 2. Okay, let's move on to station number 3. And let's look firstly at what they're asking us to do. So I can see for my first operation, they're asking me to multiply. For my second, they're asking me to divide. So they're either asking us to multiply or divide here in this table, in this station, at the station. So let's firstly add in our inequality symbols. So when I'm looking at 5 and -1, I know that 5 is greater than -1. So I'm going to add in that greater than sign in there to say that 5 is greater than -1. Now, the operation they're asking me to carry out is to multiply both sides of my inequality by 2. So I'm going to multiply both sides of my inequality by 2 right now, and I'm going to, for now, keep that inequality symbol that I originally had the same. So I've got -1 times -2 on the, or +2 on the other side. Okay, so remember when we multiply a negative by a positive, we get a negative. So on the left side of my inequality, I have 5 times 2. So 5 times 2 is 10. So here's my 10. And 10 is, or I'm sorry, I'm going to leave that alone for now. Now, -1 times 2 is -2. So now I have to ask myself, can I still say 10 is greater than -2? And I can indeed still say that 10 is greater than -2. In fact, 10 is a lot greater than -2. So if I come over here, it asks me, is my inequality symbol preserved or reversed? My inequality symbol was preserved. It stayed the same. Let's look at 3 more problems that are either multiplying or dividing to understand, does it matter if we multiply or divide by a number, a positive number to be exact, and it will either change or preserve our inequality symbol. So if I'm looking at negative